Hello, you are watching Bold Science with Firyuza. In April 2019, news outlets and popular science media announced what they called the first ever photograph of a black hole, produced by the International Event Horizon Telescope collaboration. The announcement caused a sensation and instantly spread around the world, becoming a symbol of the triumph of modern astronomy. Checkmate to everyone who didn't believe in black holes. We were indeed shown an image that was solemnly presented as the first photograph of a black hole, and almost the entire world, instantly, without doubt, without question, happily swallowed it. Newspapers, popular science magazines, public lectures, universities, television, everyone repeated the same phrase in unison, like an incantation. The first photograph of a black hole. But let's turn off the excitement and turn on logic. Let's start with a question that for some reason almost no one asked. Why in this photograph of one of the brightest objects in the universe do we see a dark spot? It's not a difficult question, not a philosophical one, not a provocative one. Just a normal physical question. At the center of the galaxy M87, there really is a compact supermassive object. That is a fact. No one disputes it. Around it, there is hot gas, superheated plasma, relativistic speeds, extremely strong magnetic fields, and intense electromagnetic radiation across nearly the entire spectrum. This is not a black dot. It is one of the brightest regions that are acceptable to observation at all. This is not a cold rock drifting through space. It is an energy fountain. And against the background of all this were shown a black spot. A central darkening, neat, almost aesthetic. However, after some time, the project's participants and many astrophysicists clarified that what we're actually seeing is not a photograph of the black hole itself, but only a photograph of its shadow. And we're told, this is a photograph of the shadow of a black hole. Fine, let's examine this calmly and rigorously. What is a shadow in physics? A shadow is not a metaphor. It is a specific physical phenomenon. For a shadow to exist, three things are absolutely required. First, an external source of light. Second, the opaque object. Third, a surface or region where the shadow is cast. If there is no place for it to fall, there is no shadow. If there is no external illumination, there is no shadow. If an object emits its own light, it doesn't cast a shadow. Now pay attention. Where in the universe is the place onto which the shadow of a black hole is supposedly cast? The answer is simple. It doesn't exist. Where is the external light source that illuminates the black hole from behind? That doesn't exist either. On the contrary, the object itself emits radiation. It's not illuminated, it shines. That is why talking about the shadow of the self-luminous object is like talking about the shadow of the sun. You can say this word. You can even say them very confidently, but no physical meaning will magically appear. This is exactly the point where a pause should have occurred. But it didn't. We're immediately given a rebuttal. This is not an ordinary shadow. It is a gravitational shadow. Photons are bent by a strong gravitational field. Fine. Then we ask the next logical question. Where is the observation here and where is the interpretation? Because the bending of photon trajectories is not something you can see with your eyes. It cannot be photographed. It is a theoretical conclusion that follows from general relativity. In other words, this is not what the telescope actually saw, but how scientists explain the data they obtained based on a theory that had already been accepted in advance. And this is where the key substitution happens. The one everything rests on. We are shown a drawn image that looks like a photograph, and it's called a photograph, but it's not a photograph. And here we come to the most important question we asked at the very beginning. Why is there a dark spot at the center of the image? The answer is simple. The black hole model predicts exactly that. not because the telescope saw darkness, not because the instrument detected an absence of photons, but because this is a reconstruction carried out within the framework of general relativity. This is not a photograph of a real object. It is a consequence of a theory. And that distinction is fundamental. Do you remember the criterion of falsifiability? A scientific experiment must be designed so that it can refute a theory if the theory is wrong. But here the reconstruction is built into the theoretical expectations from the very beginning. Do you see what this means? That is why the result was predictable. What we were shown was not a discovery, not a real photograph on an object, but a virtual image constructed within the black hole model. That is why the image looks strangely beautiful, why it fits expectations so perfectly, and why the center is dark. And that is also why the raw data were never shown to the public, because the raw data are not a ring. They are not an image, they are just a few blurry pixels, and it is hard to feel art toward pixels. People want an image, meaning, a story, and that meaning was drawn in afterward. Let's sum it up. A self-luminous object doesn't have an own shadow. A shadow is possible only with external illumination that is brighter than the object itself. Therefore, photographing the shadow of a bright object is impossible, just as it is impossible to photograph the shadow of the sun. At the center of the galaxy M87, there is a very bright, compact, supermassive object. It has no shadow. So from the very beginning, the discussion was not about the shadow of a black hole, but about what kind of shadow a compact object would create if it didn't emit light itself. If there were a bright background source behind it, the object would then capture or deflect passing photons, creating a shadowed region behind it. The geometric cross-section of such a shadow can be calculated theoretically, purely on the basis of a chosen model without any observation at all. But that would be pure theory, and it would impress no one. Within the Event Horizon Telescope project, extremely limited radio interferometric data from a bright compact source at the center of M87 were used. These data don't contain enough information to reconstruct an image. Nevertheless, they were embedded into a previously accepted theoretical model whose shape is fully determined by the theory itself. The resulting reconstruction is a purely theoretical curve into which a few experimental points were inserted after the fact solely to create the appearance of an empirical connection. These points serve a decorative function, allowing a model-based visualization to be presented as a real photograph. And all of this was presented as a major scientific achievement. But that is not all. In the next video, we will examine how much information was actually contained in the data, why we are talking about at most 4 pixels, and how a reconstruction was passed off as a photograph, because that is where things become truly interesting. You were watching Bold Science with Firyuza. Subscribe to the channel, like the video, and see you in the next episode.